Alright, so today we're talking dilations, right? And we know that we need two things for dilations. We need a distance and we need a direction. Alright, so it says dilate circle A from center 0. So from, that's my first indicator, right? That's my direction. From here, that's right here, right? And it says by the origin, right? By a scale factor of r equals 3, right? So that's my scale factor. That's my distance. That's how much I'm going to do it. Now, since point A is exactly 1, 2, 3, 4 spaces away to the right and 1, 2 spaces up, using that, A right now is 4, comma 2. So if I use my scale factor on that guy, that means A prime should be 4 times 3 is 12, and 2 times 3 is 6, so it should be a 12, comma 6 over 12 and up 1, 2, 3, 4, 5, 6. There's my A prime. And we could put other points on here, right? We could do a B and a C and a D and an E. And then we could find each one of those points. So E is over 4 and up 1. So it should be over 12 and up 1, 2, 3 times 1 is 3. And there'd be my E prime. Same with B. It's over 5 and up 2. So 5 times 3 is 15. And 2 times 3 is 6. Means that B prime should be there. But before we go ahead and finish this, do we notice how B is on the same line as A and D is also on the same line? So we know that D is going to be somewhere over here. Same with E and C up and down from A, right? E and C. And if we look, do we see how right now this has a distance from here to here of 1, from here to here of 1. So our radius, or halfway through the circle, is 1 unit. Well, when we have a scale factor of 3, that means that it's just going to be multiplied just like everything else. So it should be a scale factor of 3 where 3 is my new radius. Hey look, 1, 2, 3. 1, 2, 3. So we can kind of use that information to go ahead and fill in this last piece here. That should be C prime, and 1, 2, 3 backwards here should be D prime. And again, we know it's going to be a circle, so we're just going to kind of draw it in. It's not going to be perfect, I get it. We could sit here and try to come up with all these different points here and 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 scale it all the way out. Or we can take a handful of points. We know what the shape's going to be, and then we're just going to prove it here. So we did A. We'll prove it using D and E. Okay, so D and D prime, and then we'll use it again with E and E prime. So D is over 1, 2, 3 and up 2, 3, comma 2. E is over 1, 2, 3, 4 and up 1. Those are my originals. And D prime is over 9 and up 6. And E prime is over 12 and up 3. And we can prove that using a scale factor of 3. 3 times 3 is 9, 2 times 3 is 6, 4 times 3 is 12, and 1 times 3 is 3. We know for a fact that this is the correct answer here. Okay? If we look at this next one, it says dilate ellipse E from center 0 with the origin scale factor of 2. So again, we still have it's from here, so the scale factor is coming from here. So look, this is like, so I'm going to use this second example here. This is E, right? It says a scale factor of 2. Do as many points as you need. So look, see how that's over 2 and up 2? This should be over 2 more, or over double to 4 and up double 4. And if we notice, right, we see how this creates a line going this way. That's what we're doing here. We're doing the same thing this way. We're doing the same thing this way. So I can draw it kind of right. Right, if we had a point here, I'm going to put a point here and a point here. So I have F, and I have G. See how F is like halfway in between 2 and 3. So F itself would be like 2.5 or 2.5, comma, it's up the same height, it's still 2. And then G would be the same thing except it's back a half, so it would be 1.5, right? We see that halfway in between, 1.5 or 1.5, comma 2. So using my scale factor of 2, F prime and G prime respectively should be at 2.5 times 2 is 5, and 2 times 2 is 4, and 1.5 times 2 is 3, and 2 times 2 is 4. So I should have over 5 and up 4, and I should have over 3 and up 4 for my F prime. Remember, that's my E prime, and that's my G prime. And if we look, do you see how, like, if I had a ruler that was perfectly straight on this, I could draw something, but do you see how those lines are going to go through? And the same thing with this. If we look here, it's not perfect, but it's there, right? So we could put something here at this top piece and something here at this bottom piece. We see it's a little above here and it's a little below here, below 1. So realistically, A, B, C, D, E, F, G, H, let's call this one H, and I. So if I want to put H prime and I prime, H is over 2 and it's up just a little more than 3. It's about an eighth or a half of a half of a half. So when we double that, it would be a quarter or half of a half. So I'm going to go over to 4, right? Double 2 is 4, and I'm going to go up. Double 3 is 6, and so double 3 and an eighth would be 6 and a quarter. So this would be 6 and a half here. So I'm going to put 6 and a quarter about there. And the same thing, this one's just below, it's an eighth below 1. So that means it's going to be roughly a quarter below 2. If there's the halfway point, right, quarter puts it somewhere right about there. And hey, look, do we see how that line, I actually drew it pretty decent, right? That line there matches up with this one, right? So that's going to be my I prime, that's going to be my H prime, and I have all my stuff. We can see here, it's the same shape, and you can draw more dots to create the shape if you want, but what shape is dilated image? We know it's still the same shape. It's an ellipse, and that's because dilation itself is not a rigid transformation. Remember, a rigid transformation needs two things. It needs same shape and same size. Now, a dilation itself will never have the same size. So that's why this is not a rigid transformation, but it does have the same shape. So we already know what the shape, it says what's the shape, we already know what it's going to be if it's a dilation because the shape doesn't change, right? And finally, we have this one here. It says triangle ABC has been dilated from center 0, so from this point here, there's the point of dilation, right, is this here. And says by a scale factor of 1/4. Now that's important to note. If a scale factor is less than 1, right, 1/4 is less than 1, that means our shape is getting smaller. And if you look, there's the OG, the original geometric design, and here's the copy. How do we know that's a copy? That's right, because there are primes, right? There's a prime somewhere, C prime, B prime, A prime, those are all primes. Prime tells us it's a copy. If it's more than one prime, it tells us which copy number it is. If there's no primes, then that's what tells us that it is the original shape, or the original geometric design. So verify that it would take an R4 to go backwards. Well, do we see how 1/4 and 4/1 or 4, they're just reciprocal opposites, meaning the top number flips the bottom number flips the top number. So the way to prove this would be to measure the distance from A prime to our center of dilation, or at a point of dilation, and then we could measure A, the original, to that. This should be 4 times as much as this. And then we can prove it one other way by, let's say, measuring from like A to C and measuring from A prime to C prime, right? If that's X, that should be 4X. And what I mean by that is, let's say that like A prime to C prime, right? To measure that distance, so we actually write it as A prime C prime, and then we draw that little hat over it saying that that's the line segment, or that's the distance there, right? Is equal to, I don't know, let's say like it's 12 centimeters. I don't think it's that big, but then that means that A to C, the original, would be 4 times that amount, or 4 times 12 would be 48. That's a terrible 4, but 48 centimeters. And that would be the way to prove that. In this case, if they tell us that the scale factor is 1/4 going this way, and that means going the other way would be the exact opposite, or would be 4/1. But that would be how you would prove it on like a quiz or a test or something like that. So that is all of the classwork for Module 2, Lesson 3.